Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is EDEXCEL 2020 Paper 2, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a. Write 84 as a product of its prime factors. Now, you can do this with fact trees, so starting with 84 at the top and then thinking about two numbers that multiply together to give you 84. Well, 4 goes into 84, doesn't it? It goes in 21 times. 21 times 4, and then you can break the numbers down, so that's going to give you 3, 7, 2, and 2. So making 84 2 times 2 times 3 times 7. Now there is a quicker way. If you've got a Casio calculator, you can just type in 84 equals and then press shift fact, and it's going to tell you the same thing. It gives you it in index form, so it's written it down as 2 squared times 3 to the 7, but you can see it's the same thing. Okay, then on to B. Find the lowest common multiple, or LCM, of 60 and 84. Now there is an exhaustive approach where you can just list all the factors of 60 and 84 out, so the multiples are 60, 120, 180 and so on. But with large numbers that are quite close together, you can be there for quite a while before that you can actually find the number. Better way is to use prime factor decomposition. We already know that 84 is equal to 2 squared times 3 to the 7. Now if we can write down 60 as a product for its prime factors as well, we can use those forms to help us with the answer. So 60 equals shift fact. That comes out to 2 squared times 3 times 5. Okay, now the way I think about it is I think, well, the LCM is made up of every base that appears in one or both of the expressions. So 2 appears as a base. When I'm talking about base, if I got like 2 to the power 3, then the 2 is the base and the 3 is the index. Okay, so when I'm talking about bases, 84 and 60 have got a 2 in it. There's a 3 in both, there's a 5 in 60, and there's a 7 in 84. Okay, so my LCM is going to be made up of each base to the highest power it appears in either base. So I've got a 2 squared in both, but all the rest are just single digit ones. So it's just going to be 2 squared times 3 times 5 times 7. If you find that way of doing it tricky, some people think about it in terms of a Venn diagram, and they put the things that are in common in the middle. So that would be your 2, 2, and 3 go in the middle, and then the things that are different go in the ones at either side. So that's 5 and 7, and then you multiply all those together and that will give you your LCM as well. So that's a different way of doing it. But anyway, I'm going to crack on and work out what 2 times 2 times 3 times 5 times 7 is, and I got 420. 420. Question 2. E, the universal set, contains numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A is a set of even numbers, and B is a set of factors of 10. Complete the Venn diagram for this information. So we've got to put all those values from the universal set in the diagram. So all those need to go in. Now, if they are even numbers, they're going to go inside set A. If they are factors of 10, they're going to go inside set B. And obviously, if they're even numbers that are factors of 10, they're going to go in both. I think what I'm going to do, just before I start putting them in, I'm just going to list out what numbers we're talking about here. So even numbers are the numbers 2, 4, 6, 8, and 10 on that list, isn't it? And the factors of 10 are 1, 2, 5, and 10. They're the factors of 10. Okay, so which ones are on both? Can you see I've got like a 2 and a 10 on both? Okay, so I'm going to start with those. I'm going to put those in the middle. 2 goes in the middle, 10 goes in the middle. Okay. And then what else have I got? I've got then my even numbers that are not factors of 10 are 4, 6, and 8. So 4, 6, and 8. And my factors of 10 that are not even are 1 and 5. Okay. Now, have I got any missing? Have I got any missing from those? So just going to go through and double check my my universal set, make sure I've got them all. So I've got 1, I've got 2, not got 3, I've got 4, got 5, got 6, not got 7, got 8, not got 9, got 10. Okay, so those ones I got missing, 3, 7, and 9, they still need to go on the diagram, but they're going to go outside the two sets that I've got. So 3 goes here, 7 goes here, 9 goes here. It doesn't really matter where you put them as long as they're inside the square and outside the circles. Okay, so there we go. I think I've got all of them. I could just double check by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I got them all. Right, now part B says a number is chosen at random from the universal set. Find the probability that the number is in the set A intersect B. Okay. So what does intersect mean? Intersect means and. So it needs to be probability that it's in set A and it's in set B. Okay, it's got to be, basically it's the bit in the middle, isn't it? This is the bit we're talking about. This is in A and in B. Okay, so the probability of A intersect B is the probability of A and B, which is how many values are in that bit in the middle. There are 2. How many values there altogether? There are 10. So my answer is 2 over 10. Question 3. Carlo puts tins into small boxes and into large boxes, as you do. He puts 6 tins into each small box. He puts 20 tins into each large box. Carlo puts a total of 3,000 tins into the boxes, so that the number of tins in the small boxes compared to the number of tins in the large boxes is in the ratio of 2 to 3. Carlo says that less than 30% of the boxes filled with tins are large boxes. Is Carlo correct? You must show your working. Okay, so this is a little bit more complicated than it might first seem, because you've got boxes and tins, and you've got like percentages and ratios about each and either. So yeah, we have to kind of work through it carefully and just make sure we've got everything down. Now, and I think I'm going to start with this bit. There are 3,000 tins in total, and they're in the ratio of 2 to 3, okay, in terms of whether or not they go into large boxes or small boxes. Okay, so if I've got 3,000 tins and I want to divide it in the ratio of 2 to 3, first off, 2 to 3, 2 plus 3 equals 5, isn't it? So that means I've got 5 parts to share this 3,000 into. Okay, so if I take 3,000 and I divide it by 5, then it tells me what each share is worth. So 3,000 divided by 5, that's 600. Okay, so then the small box to large box is in the ratio of 2 to 3. So if I take that and I scale it up by a factor of 600, okay, because each share is worth 600. That tells me that there are 1,200 tins in small boxes, and there are the rest, 1,800 tins in large boxes. Okay, so that's the number of tins. I think I'm going to change that to tin S and tin L, so TS and TL. So just to make sure that I'm clear about when I'm counting tins and when I'm counting boxes. So TS means tins in the small boxes, and TL means tins in the large boxes. Okay, and then so because we've got to make sure we're clear about boxes versus tins. So I've got 1,200 tins in small boxes. Now I know that he put 6 tins into each small box. So if I divide 1,200 by 6, I should know how many small boxes there are, shouldn't I? So the number of small boxes is going to be that 1,200 tins that are in small boxes divided by 6, the number of tins in each small box. I don't need to calculate for that. I can know that's 200. And I know I've got 1,800 tins in large boxes. So the number of large boxes is going to be my 1,800 divided by the 20 tins that are in each large box. Okay, so what's that then? 1,800 divided by 20. Again, I can do that in my head. That's 90. 90 there. If you can't do it in your head, use a calculator. It's a calculator paper. So small boxes 200, large boxes 90. Now Carlos says that less than 30% of the boxes filled with tins are large boxes. Okay, is that true? Okay, well, how many boxes there are altogether? So total boxes, that's going to be my 200 small boxes plus my 90 large boxes. That's 290 boxes altogether. So then what percentage are large boxes then? What percentage are large boxes? That's going to be the number of large boxes, 90, divided by the total number of boxes, which is 290 times 100, isn't it? Okay, that's what's going to convert that fraction into a percentage. So I got 90 out of 290 as a fraction, and then multiply that by 100. That's going to tell me that 31% and a little bit, which I'm going to round off to 31.0%, percent is large boxes then. So Carlos says that less than 30% of the boxes filled with tins are large boxes. Actually, it's 31%. So actually, Carlo is incorrect, isn't he? Carlo is wrong, as 31.0% exceeds 30%. Okay, he said it would be less, it's more. Question 4a, complete the table of values for y equals 5 minus x cubed. Now, I've got a nifty function on my calculator that will do this for me. If you don't have a Casio calculator though, what you're going to do is you're going to take each of the values of x down here and you're going to sub them one after the other into the equation to find what y is. So for instance, for x equals minus 2, we're going to sub in that y then is equal to 5 minus negative 2 cubed, which is 13. And then we go on and do the next one, the next one, next one, next one. That's why they've given us all that space. But if you've got a Casio calculator, it makes life super easy. All we've got to do is press the mode button, go into table mode, which is mode 3. It's going to ask me for f of x. Now that's the function that we want to type in. It's this bit here. So we're going to type in 5 minus. Now how do I get an x? Now you notice that there is a little red x above the right bracket. So if I press shift and then, if I press alpha and then x, that x button will come up and I need it to the power 3, which is there. So 5 minus x cubed. If I press equals, it's going to ask me for g of x. I don't need g of x here. That's if I wanted to do a second function. Start value, that's going to be my lowest value of x down here. It's negative 2. End value is going to be my highest value of x. It's up here, it's 2. And step, what am I going up in? I want all the numbers in between. I want to go up in ones. Okay, so my step is 1. Now if I press equals then, it's going to give me the table of values. And if we have a look on our table of values, look, I've got -2 goes with 13. That's the one we found earlier. And I've got -1 goes with 6, which is given. I've got 0 goes with 5. I've got 1 goes with 4. And I've got 2 goes with -3. Okay, so they're all my values that I need to plot. On to part B, we're now going to plot those points on this graph. Look, on the grid below, draw the graph of y equals 5 minus x cubed for the values of -2 to 2. Now, they're the values we just found. So we're going to be plotting each of these as coordinates. So -2 goes with 13, -1 goes with 6, 0 goes with 5, 1 goes with 4, 2 goes with -3. Okay, so let's just plot those on. -2 goes with 13. So -2 goes with 13. That's halfway between 12 and 14, isn't it? It's going to be there. -1 goes with 6. 0 goes with 5. 1 goes with 4. And 2 goes with -3. Okay. So cubic curves, this is a cubic curve, isn't it? It's one with a negative x cubed term. So they kind of go down like that. They're usually like that. Or sometimes they have a bit more of a wiggle in the middle like that. But this is more like the kind of slightly flatter in the middle version. So I'm going to have to join those up with a nice smooth curve. So the most important thing is to just to skewer each of your points and just have one line. Okay? Doesn't matter if you wiggle a little bit. Okay, doesn't matter if it's, oops. That I can't do, can't have 2 lines. Doesn't matter if you're a little bit wobbly. And the worst thing, there are worse things that you can do. So like the worst things you can do is miss the points or have multiple lines. Okay, so anything other than that, you're going to get the marks for drawing your line, even if it's a little bit wobbly. Okay, so there we go. I'm all done. Question 5, I've been given this triangle with various sides and angles marked, and the question is work out the value of x. Give your answer to correct to 1 decimal place. Okay, so we've got a right angle triangle here, and I know an angle, and I know a side. Okay, and then I want to find another side. This sounds like it's a job for trigonometry, and in particular, SOHCAHTOA, which is our mnemonic for remembering the trigonometric ratios for angles in right angle triangles. Now, which one am I going to be using here? Now, I've got which sides have I got? So I've got my angle marked here. Now, 178, that's the longest side of my triangle, isn't it? It's what we call the hypotenuse. Okay, now the one opposite the angle over here, that is called the opposite. This one is next to or joins onto the angle. We say it's adjacent. Now, I don't know the adjacent, don't want the adjacent, not interested in the adjacent. Okay, so any of the ratios that got a in it, these are not for me. It's this one. Sine is equal to opposite over hypotenuse. Okay, so that's the ratio I'm going to be using, sine. I'm going to write down the full formula. Sine theta is equal to op over hyp. Okay, and then I'm going to start subbing into it, the things that I know. So sine theta, now the angle is theta, isn't it? That's 34 degrees. So that's going to be sine 34. Now the opposite, that was the thing that we wanted to find. That is x. And the hyp, that was the longest side. That was 178. Okay, so you can see there's only one thing I don't know here. That's x. So if I can rearrange this by cross multiplying that 178 up there, times in both sides by 178, I'm going to get x is equal to 178 times sine 34. Okay, we tend to write the number at the front of sine 34 so it doesn't kind of get confused at the end. So 178 sine 34. Time to reach for the calculator. Make sure you put it back into mode 1 after doing the table from earlier. Then 178 sine 34. So 178 sine 34, that comes out to be 99.53. So rounded off to 1 decimal place. X then X then is 99.5 millimeters. Now before I rush off, I'm just gonna think about whether or not that answer looks sensible in my answer over here. So if I put X up here where it belongs, does that look about right? So it's just around about 100. My longest side is 178. Okay, now it doesn't look like 2/3 of 178. It's not actually drawn to scale though, is it? I do think that is a reasonable answer for that question. I'm going to leave it in. It's going to be 99.5. Now I do recommend just having a little think like that when you get an answer. Just put it back in the diagram, just double check that it looks right. It does for me, so I'm moving on. Question 6, I've got vector A, which is defined to be by this column vector 3, 4, and B, which is the column vector 5, minus 2. We want to find 2a minus 3b as a column vector. So we've got a bit of matrix addition and multiplication here. So 2a minus 3b, that's 2 lots of my vector 3, 4 minus 3 lots of my vector 5, minus 2. Okay? I might just write that again because that minus sign got kind of sucked into the 2. So there we go. So what do we do now? So what we're going to be doing when you've got a matrix here. So a vector is just a 2 by 1 matrix, and matrices you'll find out more about at A level. But all you have to do when you multiply a matrix by a scalar like this is you have to multiply everything inside the bracket by that 2. Okay, so I'm going to get 2 times 3, which is 6, and 2 times 4, which is 8. Okay, I've got the same thing here. I've got 3 times 5 and 3 times minus 2. So that's going to give me 3 times 5 is 15. 3 times negative 2 is negative 6. Okay, and then I've got matrix addition. So you just kind of add like this one with this one, and this one with this one. Oh, sorry, subtraction. So you just need to subtract 6 minus 15. What's that? That's minus 9, isn't it? So negative 9, and 8 minus negative 6. Subtracted negative is the same as adding. That's going to be 14. So I'm going to get negative 9, 14. Now what you're finding when you're doing this is if I had if vector A looked like this and vector B looked like this, then what I'm doing is I'm doing 2a, which is A followed by another A, minus 3b. So B, B, and B. What we're doing is we're finding this vector, okay, from that way. So that's going to be my resultant vector. Okay, that's just a bit by the by though. Sometimes it's good to know what it is you're doing. That's what we're doing. All right, let's move on. Question 7. The diagram shows a right angled triangle and a quarter circle. Yes, it does. The right angled triangle ABC has angle ABC is equal to 90. The quarter circle has center C and radius CB. Work out the area of the quarter circle. Give your answer correct to 3 significant figures. You must show you're working. Right, so now to find the area of a quarter circle, if I want the area of a quarter circle, I need to know pi r squared, the area of a circle, and then I want to find a quarter of it, don't I? Because it's a quarter circle. Now in order to work that out, I'm going to need to know r. I don't know r. R is this distance from here to here, isn't it? Because we're told that C is the center of the circle. Okay, so this circle kind of is like that, isn't it? With C in the middle. Okay, and then so CB is going to be our value of R then. Okay, so in order to work out the area of this quarter circle, we're going to have to know what R is. How can we find R? Well, I think we're going to be using this triangle here, aren't we? We're going to find this triangle to find R. Okay, so I'm going to start with triangle ABC. So in triangle ABC, now R is the shorter side of a right angle triangle where I know the longer 2 sides. So I'm going to be using Pythagoras theorem, aren't I? Pythagoras theorem to work it out. Okay, now Pythagoras theorem says c squared equals a squared plus b squared, which in this case I've got 9 squared equals 6 squared plus r squared. Now to find r squared, I just need to rearrange that, don't I? So r squared is 9 squared minus 6 squared. Okay, what is 9 squared? It's 81. What is 6 squared? It is 36. What is 81? Take away 36. So r squared is 45. Now normally, if I was finding the radius, I'd want to then reach for the calculator and work out what root 45 is here, but I don't need to. Because if you look, in my original calculation, I actually had r squared, and I found r squared, so I can just sub the 45 straight in. Okay, so coming back to my my original thing that I wrote down, the area of a circle is a quarter pi r squared. It's going to be 1/4 of pi times r squared, and we know that r squared is 45. Okay, so I just need to find a quarter of 45 and times it by pi then. So what's that then? So 45 pi divided by 4 basically, isn't it? So that comes out to be 35.3 to 1 decimal place, or 3 significant figures. 35.3. What's the units? Meters squared. Question 8. Tarek buys a laptop. He gets a discount of 5% off the normal price. Tarek pays £551 for the laptop. Work out the normal price of the laptop. Okay, now this is I can see already it's a reverse percentage question, but I do all my percentage questions just using this FOM triangle, final, original, multiplier. I just find it really handy. It just gives me one method to do all the different sorts of questions. All you need to be able to do is to work out which is the final, which is the original when you read a question. Now, you have to think about the tense, like in English language. Tense means past, present, future, isn't it? So which one happened first? That's the original. Which one happened second? That's the final. So reading this through, Tarek buys a laptop. He gets a discount of 5% off the normal price. So this is a percentage decrease then, isn't it? 5% off, that's a percentage decrease. So my multiplier is going to be, well, we always start with 100% and we take off 5%, that's 95%, which as a multiplier is 0.95. Okay, Tarek pays £551 for the laptop. Work out the normal price. Okay, so which one happened first? Did the normal price happen before the £551? The discounted price, wasn't it? That was the discounted price. So it was started off being the normal price and then it became the discounted price. So the normal price is the original and therefore that is the one we're trying to find. And 551 is the final. That's the one it happened second. Okay, so when you're doing these questions, just think about past, present, future. Which one happened first? Which one happened second? And then, I think you'll find these are easier to do. Right, so that means I've been given the final, I've been given the multiplier, and I want the original. So you put our FOM on the one we want to find, stick your FOM on it, and then that tells me that the original equals final over multiplier. Okay, so original equals final over multiplier. Okay, so the final was 551, the multiplier is 0.95, so then tapping that into the calculator, tappy tap, 551 divided by 0.95, that comes out to be £580, so that was the original price. Okay, again, just think, does my answer make sense? He goes to a shop, he pays £551 in the sale, so you're expecting the normal price to be more, aren't you? And it is, okay? If you worked it out and came to like £479.68 or something, then you're not going to have to pay more in the sale, are you? It doesn't make sense. So just think, does my answer make sense before you move on with these sorts of questions? Right, now part B, Joan invests £6,000 in a savings account. The savings account pays compound interest at the rate of 2.4% for the first year and then 1.7% for each extra year. Okay, so work out the value of Joan's investment at the end of 3 years. Okay, so we're going to be working out final, original, multiplier. Now we've actually got 3 different, well, we've got 2 two different types of multiplier here, haven't we? Final is what we're trying to find. The original is the amount of the investment that she put in to start with. Now multiplier, we've got two different multipliers here. Multiplier 1, it's 2.4% for the first year. So 100% plus 2.4%, that's 102.4%, which is 1.024 as a multiplier. My second multiplier is going to be 100% plus 1.7%, and that is equal to 101.7%, which is the same thing as 1.017. I do recommend doing it the long way like that. Students often make mistakes with these zeros and getting the numbers in the right place for their multiplier. So just taking a little bit of extra care, working out your percentages properly, will fix 99% of the most common errors with these sorts of questions. Right, so then I want to find the final, so we're going to cover that up. So that's original times multiplier. So final equals original times multiplier. Now you've got a few multipliers to apply here, but should all work out. So 6,000. My first multiplier is for year 1. That was M1. That's 1.024. And then in year 2, it was, so I'm just going to add that up, I'll multiply that one on the end. So that's 1.017. We have to do that twice. So I could multiply it by another 1.017, but the other thing I can do is just square that. Okay, so that's what I'm going to get. I'm going to get 6,000 times 1.024 times, so that's the first year, 1.017 squared, because that's in both year 2 and in year 3. So that giving me 6,354.67 to the nearest penny. Okay, so £6,354.67. Question 9. Aisha recorded the heights in centimetres of some girls. She used her results to work out the information in the table. Least height was 142, lower quartile was 154, interquartile range was 70, median was 162, range is 40. Aisha drew this box plot for the information in the table. The box plot is not fully correct. Write down 2 things that Aisha should do to make the box plot fully correct. Okay. Right, so let's just go through and check what she's done. Thing 1, she has drawn a scale. That's normally what you start with. Is that correct? It's going up in tens. There's no gaps. It's all looking good. She's marked the name of the scale, so that's good. That's the first thing you should do. Right, then what? She's written on the least height, which is 142. Is that correct? That's the least height there. That does look correct. Okay, that is at 142. The lower quartile, that should be at 154. That also seems correct. This is the lower quartile. It's the left-hand side of your box. Interquartile range is 17. So there isn't anything for interquartile range. The interquartile range is the width of the box. So that should tell you that the upper quartile, which is called Q3, that's going to be the lower quartile, 154 plus 17. So 154 plus 17, that's 164, 171, isn't it? So is the upper quartile at 171? No, it's not. It's at 172. Okay, so the first error is that she has got the upper quartile in the wrong place. So my first thing is upper quartile Q3 should be at 154 plus 17 equals 171 centimeters. Okay, right, so then that's that. Now, next thing, median at 162. You have gone cropper again there, haven't you, Aisha? So she's drawn it at 161. So that's the second thing. So median should be at 162 centimeters and not 161 centimeters as she's drawn it. Okay. Now, what's the last thing she did here? Range is 40 centimeters. Is that correct? The greatest height then should be at 142. The least height plus the range, that's 182. Now, actually, that is correct. Ran out of colors. Maybe use yellow again. So then the greatest height should be 182, which is correct. That one is all right. Okay, so we found all the errors. It's the median, and it was the upper quartile that was wrong. Question 10a, simplify 1 over m squared to the power 0. Complicated thing to the power 0, it doesn't matter how complicated the thing it is. If you've got anything raised to the power 0, it's 1. Okay, so it doesn't matter how complicated the thing is, it's always going to be 1. Second one, B, simplify 8 lots of x minus 4 over x minus 4 squared. Now that's the same thing as 8 lots of x minus 4 over x minus 4, x minus 4, two brackets multiplied together. When you've got things multiplied on the top and the bottom at the same, you can just cancel them out like that. That leaves me with 8 over x minus 4. I do not believe that simplifies any more than it already does, so that is my answer. It's going to be 8 over x minus 4. Finally, simplify 3n to the power 4 w squared. Now, when you've got an index sitting outside a bracket like that and things inside the bracket multiply together, then this power 3 applies to all of the things inside the bracket. We say that indices are distributive over multiplication, if you've ever done like things like the CAD law, cumulative, associative, distributive. So indices, powers are distributive over multiplication, which means that you distribute that power to each of the things that you're multiplying together. Okay, so what does that mean? I've got 3 cubed. 3 cubed is 3 times 3 is 9 times 3 is 27. 27, or I could have just written down 3 cubed, I suppose. N to the 4 raised to the power 3. When you've got an index of an index like that, you multiply the indices together. So that's n to the power of 4 times 3, which is 4 3s are 12. And then I've got w squared raised to the power of 3. So w squared times w squared, w squared, that's w to the 6, isn't it? So 27, n to the 12, w to the 6. Question 11, Jack is in a restaurant. There are 5 starters, 8 main courses, and some desserts on the menu. Jack is going to choose 1 starter, 1 main course, and 1 dessert. He says there are 240 ways that he can choose his answer, his main course, and his dessert. Could Jack be correct? You must show how you work out your answer. Okay, well, number of ways generally is going to be the number of dishes for each of those multiplied together, and isn't it? You've got 5 starters, you've got 8 main courses, but we've got some desserts. I don't know what the desserts are. So let's say let number of desserts be n. Okay, so n, where n is a whole number. Okay, that's what n is a member of the set of whole numbers means, or you could just write down n as a whole number. Right, so I've got 5 times 8 times n. Now that is the same thing as 40n, once I know what n is. Now, if Jack says there are 240 ways, so if Jack is correct, then 40n then is going to be equal to 240. Okay, so that makes n, what would that make n? N would be 240 divided by 40. 240 divided by 40, that's 6. Okay, so is Jack correct? Well, it could be. Jack could be correct if there are 6 desserts. Now, the thing I was particularly looking for was if that ended up being not a whole number. I was expecting him to be wrong and for that number to work out to be like a decimal or a fractions, because you can't have a fraction of a pudding. So that's how I thought that problem would go. I thought we'd work it through, we'd find that n was a fraction, and that breaks the rule of desserts, because you can't be served like a 0.76 of a dessert in a restaurant, because you'd complain, wouldn't you? So yeah, but I was wrong and he was right. Yeah, it could be. Question 12. The graph gives information about the volume v litres of a petrol in the tank of Jim's car after it has travelled a distance of d kilometres. Okay, so then the volume of v litres and a distance of d litres are on the graph. You can see it starts high and ends at 0 at 300 kilometres. Find the gradient of the graph. Okay, so the gradient is equal to change in y divided by change in x, isn't it? Gradient equals change in y divided by change in x. Okay, so the change in y is going to be this amount here then, isn't it? It's that distance. Okay, so it started off up here at, what's that, 27? And it went down to 0. So the change in y then is going to be 27. Well, it's actually going to be minus 27 because it's gone down rather than up. So the change in y is in a negative direction. Change in x is this distance from 0 up to 300. So that's easy to work out. That's just 300. So we're going to be dividing by 300. So what is minus 27 over 300? 27 divided by 300. That is 0.09. So that is 0.09. I suppose that's in litres per kilometre. Okay, so interpret what the gradient of the graph represents. So that's 0.09 litres per kilometre. It's basically the consumption rate of the car, isn't it? It's telling you how much petrol you are consuming for every kilometre that you drive. It represents the rate of petrol consumption in litres for each kilometre travelled. In Jim's car. Okay, so the rate of petrol consumption in litres for each kilometre travelled in Jim's car. So his car does 0.09 litres of petrol per kilometre. Okay, so you could use that to work out, you know, how much fuel you need for certain journeys then, couldn't you? Question 13, here is a triangle ABC and we've been given various angles and sides of that triangle. Work out the length AB. Give your answer to one decimal place. So again, we've got triangles with angles and sides and we want to find other sides. In this case, it's this side here, AB. But this time it's a non-right angle triangle. So we're not going to be using SOHCAHTOA. We're going to be using one of our trigonometric rules, aren't we? Either the sine rule or the cosine rule. So normally these questions, the first thing you need to decide is which rule to use. Are we going to be using the sine rule or the cosine rule? So let's puzzle that out first. So the sine rule involves opposite pairs. So usually opposite pairs would involve, like, I know a side and its opposite angle. So, and I've got another side or angle to find and I know its opposite. Now that would work here because I've got, if you think about the yellow ones, I know those two, they go together. But I don't have an opposite here and here. Look, these don't go together. I've got an extra one over here, so that might come in. So maybe we can use that one. And then the other rule we've got is the cosine rule, which is about three sides of the triangle. You can think about the cosine rule as being about three sides of the triangle. Either you've been given three sides and you want an angle, or you've been given two sides and the angle between them and you want the third side. Now that is not the case here. I don't have three sides. and I'm not trying to find the third side given two sides. So it's definitely not the cosine rule here. So now, can I make the sine rule work then in that case? I've definitely got one pair of opposites, but actually, if you think about it, I've got two angles of a triangle, and I know that the angles in a triangle sum to 180 degrees. So I know straight away that 34 plus 26 plus my angle A, that is going to be equal to 180, isn't it? Okay, so 34 and 26 together, that makes 60. So 60 plus A is 180, which makes angle A equal to 120. So I do actually have two pairs. I've got the green pair, and I've got the yellow pair. I've got the angle of the yellow pair, and I want the yellow side. Okay, so yes, I think I can use the sine rule here. Okay, so the sine rule, you can write it either way up. You can write it with the angles on the top and the sides on the bottom, or you can write it with the sides on the top and the angle on the bottom. Now, I tend to write it down in the way that matches the question that I'm answering. Here, I'm finding the sides, so I'm going to write down the sine rule in terms of the sides on the top. Okay, so this is side C because it's opposite angle C. This is side A because it's opposite angle A, and this is side B because it's opposite angle B. Okay, so in this triangle, my sine rule says side A over sine angle A is equal to side B over sine angle B, which is equal to side C over sine angle C. Now, there's always one bit that you don't use for the sine rule. In this case, it is B, isn't it? Because I'm not interested in that one. Okay, so I'm going to cross out B. So actually, I want A over sine A is equal to C over sine C. So I'm going to start subbing in things that I know. A is 23.8. Sine A is sine 120. And that's equal to C. Well, that's the thing I'm trying to find, isn't it? And then sine C, which is the sine of 34. Okay? So now I just need to rearrange for C. And I'm going to do that by cross multiplying that sine 34 up there. So I'm going to get C is equal to 23.8 sine 34 over sine 120. Okay. Reach for the old calculator. 23.8 sine 34 divide by sine 120. That gives me 15.367. I'm going to round it off to one decimal point. So that's 15.4. So C is equal to 15.4 centimeters. Now again, just before I move on, I'm just going to see, does that look sensible there? Okay, 15.4, does it? Well, the longest side there is that 23.8. It looks reasonable. I'm quite happy with that. Doesn't look out of place. So yeah, I'm going to move on. Question 14. Here are two squares A and B. The length of each side of square B is 4 centimeters greater than the length of each side of square A. The area of square B is 70 centimeters squared greater than the area of square A. Find the area of square B. Give your answer correct to 3 significant figures. You must show all your work in. Now, when you know things about something but you don't know the things themselves, this is a good time when you should be using algebra. Okay, so I don't know the side of length A, but I know that B is 4 centimeters greater than the side of length A. Okay, so that's a classic example of where you should be using algebra. So we're going to say that the side of square A is going to be x, and therefore we know that the side of square B, which is 4 centimeters greater, is going to be x plus 4 then, isn't it? Okay. The area of square B is 70 centimeters squared, so we know what this area is. It's 70 centimeters squared. Okay. Sorry, greater than the area of square A. Okay, now I don't want to create a new thing and say this is A and this is A plus 70. What I think I'm going to do is I'm going to work out what the areas of each of those things are, given the things I already know about them. So I can work out the area of a square if I know its length. So I don't need to introduce any more algebraic terms. I just need to work out what these two lengths are, and then I can bring them together with that second statement there. Okay, so area A is equal to x squared, isn't it? And area B is equal to, well, it's going to be x plus 4 times x plus 4. Okay, if you know your perfect square identity, that's very easy to multiply out. That's x squared plus 8x plus 16. Do you know your perfect square identity? A plus b all squared equals a squared plus 2ab plus b squared. So when I multiply out a double bracket like this, I just know that the first term is going to be this thing squared, my last term is going to be this thing squared, and the term in the middle is going to be those two things multiplied together and doubled. So the first term squared is x squared, the last term squared is 16, and the middle term is going to be 2 times x times 4, which is 8x. Okay, so that's how I do it. Otherwise you can do, like, you know, normal FOIL like you normally do, but it just kind of speeds things up if you know that if you know that identity. Okay, so if you didn't, one for you to put into your toolbox. Right, so let's crack on. So I know the areas now in terms of x, and I'm told that the area of side B is 70 centimeters squared greater than the area of side A. So that means if I take the area of side A and add 70 to it, it should be equal to the area of side B. Okay, in other words, x squared plus 8x plus 16 is equal to x squared plus 70. Okay, so this thing is equal to this thing, add this thing. Okay, so you can see where all the bits came from. Right, so then I can well, straight away I can cancel these off because x squared equals x squared, so they can disappear. And then I just need to solve it. It's a linear equation, isn't it, in x that I can solve. So if I take 16 away from both sides, I'm left with 8x, because they'll cancel, leaving you 8x. And on the other side, I'm going to get 70 take away 16, that is 54. And then x then is 54 divided by 8. 54 divided by 8, that is 6.75. Okay, so we're not quite done, are we? If x is 6.75, remember we wanted to find the area of square B. Now, we found x, which is the length of side A, so that's 6.75. So that means that the length of side B, which is 4 centimeters more, that must have been 10.75. And so the area of B is going to be 10.75 squared then, isn't it? So what is 10.75 squared? 10.75 squared is 115.56. To three significant figures, I'm going to round that up. I'm going to say that is 116 then. 116 centimeters squared. Question 15, describe fully the single transformation that maps triangle A onto triangle B. Okay, so triangle A is my original, it's my object, and triangle B is my image. It's what I get after the transformation has happened. Now look at those straight away, I can see that B is bigger than A, and the only sort of transformation for GCSE that you need to know about that changes the size of a shape is enlargement. So I know straight away that this is an enlargement. Now, when I describe an enlargement, I need to know two things. I need to know the center of enlargement, and I need to know its scale factor. Okay, they're the two things I need to add on to that. This is probably a 3-mark question. So enlargement 1 mark, center 2nd mark, scale factor 3rd mark. Right, so where is the center? Now, the easiest way to find a center of enlargement is using the fact that if you draw ray lines between each point on your object and matching points on the image, okay, so if I join that one to that one with a ruler, I get what's called a ray line. So let's just draw that on. So there's one ray line. Now the other one from those two endpoints up here are just going to go along that same ray line, so they're not going to be any help. But this one matches with this one over here, so I can join those up as well. Now you should find that your ray lines converge on the center of enlargement. Now annoyingly, my line should actually go kind of halfway between where my ruler wants to go. What I'll have to do, I think it'll be good enough, I can see where the center is. So the center of enlargement then is that point there where those two ray lines cross. Okay, so that is the center. Okay, so what is that coordinate? That is the coordinate 1, 1. Okay, so 1, 1. I'm doing good. I've got my second mark. Final mark is the scale factor. Now to find the scale factor, I've got to find a matching side on object and image and work out how much bigger one is compared to the other. Okay, well on my object that's 2 units. On my image that is 3 units. So the scale factor is going to be 3 over 2 or 1.5. Okay. Now, because the object and image lie on opposite sides of the center of enlargement, the scale factor is considered to be negative, so we put a minus in front of that. So it's 3 over 2 times bigger, but it's on the opposite side of the center, so therefore the scale factor is negative 3 over 2. Question 16. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay. Now, the most popular way for this to be taught, I believe, is looking at second differences and using a kind of a convoluted way of piecing those two together. So the second differences here, for instance, are going to be 11, 21 take away 38 is 17. 38 taken away from 61, that is 23, and 61 taken away from 90, that is 29. Okay, and then so that's what we call the first differences. The second differences are the differences of the differences. So you can see that's 6, 6, and 6. Okay, so normally when people are taught how to do this, they're taught to find the second difference, take that value of 6 and halve it, and then that is going to give you your n term, 3n squared. And then you have to work out the rest. You have to kind of then work that out and take it away and all that sort of palaver. But actually there's a different way that you can do it that I want to show you. Well, maybe let's just finish this method off first, and then I'll show the alternative way of doing it, which I think is nicer. So 3n squared. So if n is, remember this is when n is 1, n is 2, n is 3, n is 4, n is 5. Okay, so this sequence, if n is 1, 3n squared would be 1 squared times 3. It should be 3. When n is 2, 2 squared is 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And then 4, n squared is 16 times 3, 32, 48. And then 5 is 25 times 3 is 75. So then you work out the differences between your original sequence and this sequence for 3n squared. So what's that then? So the difference is 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, and 9 take away 75, that is 15. Okay, so now what we've got left with, I hope you can see, is a linear sequence. So this has got a common difference this time. It goes up in twos, 2, 2, 2, 2, which means it's got to do with 2n. Okay, but it's not quite 2n, is it? Because 2n would be 2, 4, 6, 8, 10, and we've got 7, 9, 11, 13, 15. And that is 5 more than 2n. Okay, so then we combine these 3 bits together to work out that the nth term then of this quadratic, therefore nth term is 3n squared plus 2n plus 5. Okay, so now the reason I'm not so fond of this method is that, you know, why 3n squared minus, do you even know why you have to halve it there? It's just kind of learning a way of doing something. You don't really understand why it is what it is. Okay, well, that's the reason why I don't particularly like it. So we're basically teaching students how to do something. We're not teaching them why. When we're teaching this method, they rarely understand why you have to take the 6n, the common difference and halve it, and that gives you 3n squared. They don't really make the connection. So I tend to teach it a different way. I use it with the general forms of a quadratic. So if it's a quadratic sequence, then the general form of a quadratic is a(n squared plus bn plus c, isn't it? That's the general form of the quadratic, okay? Where a, b, and c are some constants, okay? Now, when n is 1, that's the first term of our sequence, isn't it? So when n is 1, then a(n squared plus bn plus c, I'm going to have 1 squared times a, that's a, plus 1 lot of b, which is b plus c, okay? And I know that that is equal to the first term of my sequence. It's actually equal to 10. Okay, now when n is 2, then an squared plus bn plus c, an squared, take n, 2, and square it, 4. I'm going to get 4a plus bn, which is 2b plus c. That is equal to my second term. That is equal to 21. Okay, and then when n is 3, n squared is 9, so that would be 9a plus 3b plus c, and that is equal to our third term, which is 38. So what we do instead with this, we kind of, and that's, you just kind of stop there. What we're doing is we're forming 3 simultaneous equations in a, b, and c, which we can then go on and solve simultaneously. Okay, now you might think, oh, simultaneous equations is horrid. Why on earth would we do it this way? This is really complicated. But actually, this bit here is the same no matter what sequence, quadratic sequence you're given. You always get this. So the only thing that you have to do is kind of bolt on your extra terms that you've been given from the actual sequence to form your equations. And then the technique becomes very similar. So after you've done a few this way, it comes really, really easy. Okay, so I've got 3 equations in 3 unknowns, a, b, and c, which I'm going to go on and solve. So the first thing I'm going to do is going to take equation 2, and I'm going to subtract equation 1. So equation 2, this one, subtract equation 1, which is this one. So what's 4a plus 2b plus c if I take away a plus b plus c? So kind of taking those away, I'm going to get 3a plus b, and the c's are going to cancel, so I'm going to get 3a plus b, and that is going to be equal to 21 take away 10, and 21 take away 10 is 11. Okay, and then I'm going to do the same thing. I'm going to do equation 3 take away equation 2, so then I've got equation 3 is this one, equation 2 is the yellow one. So taking the blue one, yellow one away from the blue one, so then 9a take away 4a is 5a, and 3b take away b is b, and 38 take away 21 is 17. Okay, so now I'm left now with 2 equations in 2 unknowns. Okay, so that's my second step. And now what we're going to do is we're going to take one of those away from the other. So that's going to be in my equation 4 and my equation 5. And now I'm just going to take 4 away from 5. So equation 5, take away equation 4. What's that then? So equation 5 then is this one. Equation 4 is this one. So if I'm taking equation 5 and I'm subtracting equation 4, what do I get? That's going to give me 2a is equal to 6. So a is 3. And once I know a, I can then sub it back into one of either 4 or 5 here. So 3a plus b is equal to 11. So 3 lots of 3 is 9. 9 plus what is 11? That tells me b is 2. Okay, and once I know b, then I can sub all those back into the first equation. A plus b plus c is 10. So a plus b is 5. And then what do I have to add on it to get 10? It must be 5, so c is 5. Okay, so there are my solutions. A is 3, b is 2, and c is 5. Then going back to our original form, a squared plus b, an squared plus bn plus c, just got to sub those values in. Therefore, nth term is equal to 3n squared plus 2n plus 5. Okay, so this draws on your knowledge of solving simultaneous equations. You might think, ugh, that looks hideous, I don't want to do it that way. But I would recommend giving it a go, because it's always the same. When you're doing this, no matter what quadratic you're doing, you'll find that 90% of the method is the same for every question, and you just get quite good at doing it. Okay, so try it. You know, I'm not saying you have to do it this way, but I'm saying I think it's a better method, and students who do learn it this way tend to do quite well at it. So yeah, give it a go or not. Question 17, write down the coordinates of the turning point on the graph of y equals x plus 12 all squared minus 7. Okay, so the turning point of a graph here is going to be the lowest point on the graph, isn't it? Okay, now how can you make that equation the lowest it can be? Now the lowest it can be, it's got a square in it, and the lowest value a square can take is 0, because 0 squared is 0. Negative numbers end up being positive, and positive numbers end up being positive, and they are all bigger than 0. So the smallest value it can be is if that bracket is 0, and that bracket is equal to 0 when x is equal to minus 12. Has to be minus 12, because minus 12 plus 12 is 0, and 0 squared is 0. If that is the case, if x is minus 12, then y is going to be 0 squared minus 7. That is going to be negative 7. So then the coordinates of this point are minus 12, comma, minus 7. Question 18. The diagram represents a solid cone. The cone has a base diameter of 20 centimeters and a slant height of 25 centimeters. A circle is drawn around the surface of the cone at a slant height of 10 centimeters above the base. The curved surface of the cone above the circle is painted grey. Work out the area of the curved surface of the cone that is not painted grey. Give your answer as a multiple of pi. You must show all of your working. Okay. Now that little bit at the bottom, the unpainted section, is what we often call the frustum of a cone. It's like a cone with the top cut off. Okay. Now we're not actually cutting the top off here. We are just painting the top part and not painting the bottom part. But the thing is, when you're dealing with frustums, you have to remember that the larger cone and the smaller cone are what we call mathematically similar. Okay, so that means that the ratios between the lengths, areas, and volumes follow a pattern that you can learn. Okay, and that's what we're going to use here. So when we've got mathematically similar shapes, so for similar shapes, if their lengths are in the ratio of a to b, then their areas are going to be in the ratio of a squared to b squared, and their volumes are going to be in the ratio of a cubed to b cubed. Okay, now that is true for all similar shapes. Okay, so it's a good thing to know, okay, and also to bear in mind when you're answering these sorts of questions. Okay, right, so what we want to know is, to start off with, we want to know what the ratio of their lengths are. I think if we can find this, okay, then we can then find the area ratio and use that to work out how much paint we're talking about here. Okay, so let's have a look at the slant height of the big cone. It's this distance here. That is 25. Now the slant height of the smaller cone is actually, well, it's this bit here, isn't it? Which is 25, the slant height of the big cone, minus this bit down here, minus this 10 down here. Okay, so that's going to be 25 minus 10. That's 15 centimeters. So the slant height of the small cone is 15. And the slant height of the big cone is 25. And that means that the ratio of their lengths for these similar shapes is in the ratio of 15 to 25. Okay? Now they cancel down, don't they? Because they've both got a 5 in them. I can divide those both by 5. What's that going to give me? That's going to give me the fact that they're in the ratio of 3 to 5 then, isn't it? Okay? So if that is the case, so if I know the ratio of their lengths, I can easily find the ratio of their areas by squaring those. So 3 squared is 9, 5 squared is 25. So that means that the ratio of their areas is 9 to 25. Now we're talking about the surface of this cone that we're painting, which is definitely one of these areas. So we know that the area of the big cone is going to be 25 for every 9 you've got on the smaller cone. Now for the large cone, the curved surface area is going to be pi RL, isn't it, using the formula that they gave us, which is pi times r. What's r? Well, r is going to be half that diameter, isn't it? I've got the diameter given as 20. So half that is going to be 10. So half of 20 is 10. And the slant height, we already knew, was 25. Okay? So that means the curved surface area of the large cone is 250 pi. Okay? So then, if this is 250 pi here, that means that the curved surface area of the small pi, of the small cone, is going to be, well, that is 10 pi greater than 25, isn't it? So if you think about it from here to here, 25 times what is 250 pi? That's 10 pi bigger. So if I multiply this up by a factor of 10 pi, that means the area of the smaller cone is going to be 90 pi. Okay, so the area of the small cone is 90 pi. The area of the big cone is 250 pi. So we want that bit down there that's unshaded, and that is the difference between the two. So therefore the unpainted surface, that's going to be the area of the large cone minus the area of the small cone, which is equal to 250 pi minus 90 pi, and that is 160 pi. I've given my answer in terms of pi. I think that's it. Question 19. A hot air balloon is descending. The height of the balloon n minutes after it starts to descend is hn meters. The height of the balloon n plus 1 minutes after it starts to descend is hn plus 1 meters. Is given by hn plus 1 equals k times hn plus 20, where k is a constant. The balloon starts to descend from a height of 1200 meters at 0,915. At 0,916, the height of the balloon is 1040 meters. Work out the height of the balloon at 0,918. Okay, so we've been given like a sequence here that has been given iteratively, haven't we? Because we've got like hn plus 1 here, so the next term in the sequence is something to do with the previous term in the sequence. So this is like a term-to-term rule where hn is the time n minutes after it starts to descend, and hn plus 1 is like a minute later. Okay, so presumably if this is some sort of sequence, then u1 can be the height at 9:15 then. So at 9:15, our first term in this sequence, u1, is going to be 1200 meters, isn't it? Because that's given in the question, height of 1200 meters at 0915. Okay? Then we're also given it a minute later at 0916. We're told the height is 1040 meters. So at 0916, u2 is equal to 1040. Okay, so our second term is 1040. And then another minute passes and it's 0917, and another minute passes and it's 0918, and that is the time that we need to work out the height for, isn't it? So we need to work out the height of the balloon at 0918. Okay, which will be u2, u3, u4. It'll be our fourth term of the sequence, won't it? Okay. So now the problem is we don't know what k is to start with. So we've got this value of k here, but we don't know what it is. But we've got two values that go together. We've got u2. I suppose we should have just used h, shouldn't we? Should have used h1, h2 for those. I'm going to just change those to h1, h2, h3, h4, so it kind of matches that one. I usually use u1, u2 for terms of a sequence, but this one is given in terms of h and n, so I might as well stick with the values that they've given me. So h1 is 1200 and h2 is 1040. So h2 should be k times h1 plus 20 according to our formula up here, shouldn't it? Okay, so the next term in the sequence, h2, should be k lots of the previous term plus 20. But we know what h2 is, it's 1040, and we know what h1 is, it's 1200. So the only thing we don't know there is k, isn't it? So we can use those first two terms to find what k is. So take in 20 away from both sides. I'm going to get 1020 equals 1200k then. So then dividing both sides then by 1200, then I'm going to get k is equal to 1020 over 1200. Just wondering if that cancels down a little bit into something a bit neater. So I'm just going to tap that fraction into my calculator to see if I can get it to simplify it down a bit for me. Yeah, that's 17 over 20. That's a little bit more easy to handle. So 17 20ths. Okay. Right, so we know what k is now. So then we should be able to use the formula then for working out what the next term is then. So hn plus 1 is then going to be 17 lots of hn over 20 plus 20 then, isn't it? Okay, so I can set that up on my calculator. I'm going to just start with the initial value so I can show you it works. So I'm just going to type in 1200 and then press equals, so it's the last calculated value. And then I'm going to type in 17 over 20 times answer plus 20. Okay, so basically I've got my 17/20ths of my last calculated value plus 20, and my last calculated value was 1200, which was h1. So if I press equals, it should give me 1040, which is h2, which it does. So then if I press it again, I should get 904. That's going to be h3, and then h4 then is going to be 788 2/5 apparently, which as a decimal is 788.4. Okay, is that my answer? Balloon starts to descend, blah blah blah. At there, the height, work out the height at 0918. I think I've done it, haven't I? That's everything. So it's 788.4. Question 20. There are only red sweets and yellow sweets in a bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says that the probability that the sweet will be red is 7 over 10. Show why the probability cannot be 7 over 10. Okay, let's go through this line by line. There are only red sweets and yellow sweets in the bag. Therefore, the red sweets plus yellow sweets equals all the sweets. There are n red sweets in the bag. So that means there are n plus 8 sweets in the bag altogether then, isn't it? So total sweets equals the n red sweets plus the 8 yellow sweets, give me n plus 8 altogether. Sajid is going to take a sweet at random. He says the probability to get the sweet or red is 7 out of 10. Well, if that is true, then the probability of red, that's going to be our n red sweets, successful outcomes divided by total outcomes, n plus 8. Now, can you make n plus 8 into 7 over 10? I do not believe so. If n over n plus 8 is equal to 7 over 10, can that be true? Well, I suppose I could cross multiply this and find out, couldn't I? What about if I cross multiply that up there and that up there? Then I'm going to get 10n equals 7 lots of n plus 8, which is 10n equals 7n plus, what's that? 7 eighths are 56. So that means 3n is equal to 56. So then to find n, we need to divide both sides by 3. That would cancel, and that will leave you with n is equal to what? What's 56 divided by 3? 56, that comes out to be 18.6 reoccurring, so that's 18.7 sweets. So it cannot be that then, because n needs to be a whole number. Okay, you can't have 18.7 sweets, and you can't have 18.7 plus 8. You can't have 26.7 sweets in total. Okay, so that's not going to work. So I can say cannot be 7 over 10 as n must be a whole number. In part B, we're told that after Sajid had taken the first sweet from the bag and eaten it, he is going to take at random a second sweet from the bag. Given that the probability that both of the sweets he takes will be red is 3/5, work out the number of red sweets in the bag. You must show all of your working. Now remember from the first part, we had that there were n red sweets, we had 8 yellow ones, and then altogether total is n plus 8 in total, wasn't there? Okay, so that's what we're going to be using here. So if we had like a tree diagram, okay, so then this would be picking red, not red, red, not red, red, not red. Then we know that this root here is the probability of getting red, red, and we know from the question that was given as 3/5. Okay, now we get that red, red by multiplying these two branches together. So the first one of picking red and the second one of picking red. Now we don't know what those are yet, do we? But we do know that we had n red ones out of a total of n plus 8 sweets for the first selection, and then for the second selection we're going to have one less red and one less total. So rather than having n plus 8, we're going to have n plus 7. Okay, and then we're going to get those that 3/5 by multiplying those two things together. So that means that n over n plus 8 multiplied by n minus 1 over n plus 7, that must have been equal to 3/5. Okay. So bringing those together, I'm just going to make those into one fraction on the left. So that's n minus 1 over n plus 8 n plus 7, and that is equal to 3/5. Okay, so then cross multiplying, so moving that up there, moving that up there, I'm going to get 5 lots of n minus 1, and that is equal to 3 lots of n plus 8 n plus 7. Okay, now multiplying the left hand side out is pretty easy. 5n times n is 5n squared. 5n times minus 1, that's minus 5n. That's equal to, just going to do the double bracket first, n plus 8, n plus 7, that's going to be n squared plus 8n plus 7n plus 56. Okay, and that is equal to 3 lots of n squared plus 15n plus 56. And then removing the bracket, then that's going to be 3n squared plus 15 times 3. 15 times 3 is 45n, isn't it? 45n, and then 3 times 56 is 150 and 168. Okay, so then that stayed the same in both of those. Okay, then it's a matter of collecting like terms, isn't it? Now I've got 5n squared on the left and 3n squared on the right. So taking 3n squared away from both sides, that's going to leave me with 2n squared. I've got minus 5n on the left, and I've got positive 45n on the right. So taking 45 away from both sides, that's going to give me minus 50n. And then I've got plus 168 on the end there. So taking 168 away, I'm going to get minus 168, and that is then equal to 0. Okay, now I can simplify things just by dividing everything through by 2, because they're all even numbers, and I've got a 2 in front of my n squared term. So just dividing everything by 2, I'm going to get n squared minus 25n minus, what's half of 168? That's 84. So n squared minus 25n minus 84. Getting somewhere, I feel like we are. Okay, does that factorize? I hope it does. That's going to make my life a whole lot easier. Factor pairs of 84. What are they then? Factor pairs of 84. We've got 1 and 84. 2 and 42. 3. Yeah, 3 goes in. 3 and, what's that? 28. 4 go in, yep, 4 and 21. Now I could go on, but I think I've already spotted the one I want. I want this one here, isn't it? 3 and 28, because 3 and 28 have got a difference of 25. So I think this is going to be n plus 3 n minus 28 then, isn't it? Okay, and that is equal to 0. Meaning that n is minus 3, which is impossible, or n is 28, which is possible. So n can't be minus 3. I'm going to cross that one out. It's not a proper solution. So n is 28 then. Therefore, number of red sweets, which was n, is equal to 28. Okay. Question 21, the graph of the curve with equation y equals f of x is shown on the grid below. On the grid above, sketch the graph of the curve with the equation y equals f of minus x. Right, now this is one of our transformations of curves that we need to know about. There are 6 altogether. We need to know 2 translations, 2 stretches, and 2 reflections. Now this one is one of the reflections, isn't it? y equals f of x goes to y equals f of minus x. Okay, what we're doing here is we're switching the positive x values for the negative x values, so that has the effect of flipping the graph, reflecting the graph in the y-axis. Okay, so if I reflect this graph in the y-axis, so let's take the discernible points on my graph, like those points there that lie on the coordinates. I'm going to take each one of those and reflect it. Okay, now the point at minus 4, 2, that's going to reflect over here to 4, 2. The point at minus 3, 0 is going to go to 3, 0. And then the point, oh, there's another one there I can do. I can do that point there at minus 2, 1. That's going to reflect over to 2, 1. And then I've got one at minus 1, 2, which is going to go to 1, 2. And then that one's going to reflect onto itself. Okay, so they're the points that I need. So after I've done those reference points, it's just a matter of then joining them up to get my solution. Okay, now for part B, it says the curve C with equation y equals 5 plus 2x minus x squared is transformed by the translation to give curve S such that the point 1, 6 on C is mapped onto 4, 6 on S. Find the equation for S. Okay, so this point here then, 1, 6, is mapped onto this point here, isn't it? Okay, now that is a translation, isn't it? It's been translated 3 units to the right. Okay, so f of x goes to, it's a translation of 3 units in the x direction. Now if I pull back up my handy list of all the types of transformations there are, you'll see that for a translation of 3 units in the direction of x, that is f of x goes to f of x minus k. Okay, it's for k units in the direction of x. So that means this one is going to go from f of x to f of x minus 3. Okay, so this is f of x goes to f of x minus 3. Translation of 3 units to the right in the direction of x. So my equation for C going to S then, my equation for C was y is equal to 5 plus 2x minus x squared. That is going to go to y is equal to 5 plus, now rather than having x, we're going to have x minus 3, and minus, rather than having x squared, I'm going to get x minus 3 all squared. I'll just budge this over because I think it might be falling off the edge. So y equals 5 plus 2 lots of x minus 3 minus x minus 3 all squared. So basically every time we saw x in here, look, which is here and here, I'm going to replace it with x minus 3. So the 2x became 2x minus 3 and the minus x squared became x minus 3 all squared. Okay, so then all we got to do is then kind of simplify all that out then. So multiply out the brackets and recollect all the like terms together. So I'm going to get 5 plus 2 lots of x minus 3, that's 2x minus 6 multiplying out the brackets, minus, I'm just going to do the quadratic underneath and then deal with the minus sign afterwards. So I've got x minus 3 times x minus 3, haven't I? Which is 5 minus 6, that's minus 1, isn't it? So that's 2x minus 1, just collecting those 5 and minus 6 together, and then minus whatever this bracket is multiplied out. That's going to be x squared minus 6x plus 9, using that handy identity for perfect squares I was talking about earlier. And then removing the brackets, 2x minus 1 minus x squared plus, because minus and minus is a plus, 6x minus 9. Okay, so what's that then? So I've got a term, one term in x squared, so that's minus x squared. I've got some terms in x, 2x and 6x, that makes 8x. And then I've got minus 1 and minus 9 making minus 10. So minus x squared plus 8x minus 10. Okay, so that is my equation for S then. Y equals minus x squared plus 8x minus 10. Now I just checked the mark scheme and it looks like they gave full credit for this one up here. So actually all this down here was extra work in that wasn't necessary. It does actually say an equation rather than the most simple equation, which is probably, I was just thinking that I needed to tidy it up. So yeah, I just spent a bit more time on that one than I needed to. You could have got all the marks for just saying y equals 5 plus 2 lots of x minus 3 minus x minus 3 all squared. So that was fun though, wasn't it? Question 22. C is a circle with center the origin. A tangent to C passes through the points minus 20, 0 and 0, 10. Work out the equation of C. You must show all of your work in. Now, when you've got a question like this, which is all words and no diagram, I think it just makes life really difficult. So I would recommend highly that the first thing you do in a question like this is to try and draw a sketch, try and imagine it. Otherwise, it's just too much to try and keep in your head. I think a diagram really, really helps. And I always recommend students to sketch these things before they do anything else. So what we got here, we got a circle which is centered on the origin. So let's just draw a circle centered on the origin. So there's my circle. And then let's just draw some lines through it. Okay, so that's the origin, so 0, 0. A tangent to C passes the points negative 20, 0. If you've got like minus 20, 0, it's down there on the number line, isn't it? And then 0, 10 is more like that. So we're going to have a kind of a slanty line here, which has a gradient of about a half. And so it's going to look something like that. So if it's just touching the circle with a gradient of a half, then it's going to be a line that looks something like this. Okay, so let's just extend that line out a little bit then. So then that there then is the point minus 20 on the x-axis. And that point up there where the line passes through again is at 10, okay? And we know it touches the circle at this point here. We would just want to work out the equation of C, the circle. So what we're going to then need to know probably is that distance there then, aren't we? Where it touches the circle. We're going to need to know the radius because that's how we define the circle. A circle as equation x squared plus y squared equals r squared. But somehow then we're going to have to work out the radius of the circle, probably by working out that distance between the point of contact with the circle and to find out the radius somehow. I'm sure it'll come together. Let's crack on. I think the first thing I want to do is find the equation of this tangent. So equation of a tangent. So we can use the gradient m, which is equal to y2 minus y1 over x2 minus x1. So if we make the point on the right, this one up here, the ones to do with 2's, and this one the 1's. So then this one is going to be x2 2y2 then, and this one is going to be x1, y1. So subbing that into my formula for finding the gradient, y2 then, y2 is 10, y1 is 0, so that goes there, minus 0, and then x2 is there, look, that's 0, 0, minus x1, which is there, that's minus 20, negative 20. So I've got 10 minus 0, that's 10, and I've got 0 minus negative 20, that's 20, so it's a half. I did say it was a half earlier, didn't I? But anyway, we worked it out properly now. So that means that the equation of tangent is going to be of form y is equal to mx plus c. But we know what m is. M is, we just found out, it's a half. So it's y is a half x plus c. And we know one of the points it passes through, could use either minus 20, 0 or 0, 10. I'm going to use 0, 10 because it's not negative. So 0, 10. So if I sub those in, y is 10, isn't it? 10 equals a half of 0 plus c. So half 0 is 0, c is equal to 10. That means that c is 10. So therefore, equation of tangent is equal to y is equal to a half x plus 10. Okay. Okay, so we dealt with the tangent. Let's have a look instead at the equation of the radius then that we drew at the point of contact with the tangent. Okay. Now, a radius and a drawn at a point of contact with a radius is at 90 degrees, isn't it? So if I say that's actually m1, okay, m1 is a half. So we know that the gradient then of this radius is a normal to the tangent. So the gradient m2 is going to be minus 1 over m1, isn't it? Okay, it's the negative reciprocal of the line that it's perpendicular to. So if you remember, m1 is a half, so turn that over, half becomes 2 and negate it. That tells me that the gradient of that radius I drew on has a gradient of negative 2. Okay, how does that help me? So therefore we know the equation of radius is going to be of the form y equals minus 2x plus c. Let's call that like c1, 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 c2. So what is our c2? Well, remember also it passes through, we know a point it passes through the origin, doesn't it? Passes through 0, 0. Down here, look, we know that radius passes through the origin. So that means when x is 0, y is 0, that tells me that 0 must be equal to minus 2 lots of 0 plus c2, telling me that c2 must be 0. And therefore, the equation of radius is equal to, is just y equals minus 2x then, isn't it? Okay. Now what we want to know is the length of that line. I think what we're going to do first, if we can find the coordinates of the point where these two lines cross, then we can work out, like, you know, the x distance and the y distance from there, and we can work out the length of the line. And once we've got the length of the line, then we know the length of the radius. Then we know the equation of the circle. So we've still got a bit of work to do. We need to find the intersect now, I think. So if we call this one equation 1 and this one equation 2, then we kind of want to solve them simultaneously then, don't we? So I'm going to solve by substitution this time because I've got y is equal to and y is equal to, haven't I? So I can just kind of plug the two different halves together. So that is going to give me a half x plus 10 equals minus 2x. So bring in all the x's to one side and everything else to the other. So I'm going to get 2x plus a half x. That's 2.5x, or 5x over 2. And that is equal to minus 10. So then multiplying by 2 and dividing by 5, I'm going to get x then is equal to, what's that? Minus 20 divided by 5, negative 4. And if x is negative 4, then y is going to be, substituting back into equation 2, that's obviously y is negative 2 lots of negative 4, that's positive 8. So then that point there is at negative 4, 8 then, isn't it? That's negative 4, 8. Okay, so what is the length of r then? I think we're getting close now. So I'm going to use the fact that this one here must be 4 and that must be 8. And I'm going to use Pythagoras theorem in this triangle to work out what the radius is. So this side here, that's going to be r is equal to 8 squared plus 4 squared, all square rooted then, isn't it, using Pythagoras theorem. So 8 squared is 64, 4 squared is 16, 64 plus 16, 74, that's 80. So that's root 80. Okay, so if r is root 80, then I've got it, haven't I? Because then x squared plus y squared equals r squared. I'm going to get the square of r is the square of root 80, which is 80. And so therefore, the equation of the line then, so x squared plus y squared then is going to be root 80 squared, which is just 80. Okay, so that's my solution. So that was pretty long. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.